Hi, and welcome to this section of the Basic Math Word Problem Tutor. And in this section, we're going to switch gears and start talking about percents, word problems that involve percents. And in fact, this section is what I call percents part 1. It'll kind of have some problems dealing with percents, sort of easing into it. And then the next section will be percents part 2, which will just be some additional problems that are of a little bit different type. But I want to ease into it and make sure we really understand this, because percents, you know, the truth of the matter is, if you understand what a fraction is, and we've been dealing with fractions for the last several sections, then you already understand what a percent is. It's just that you may not know that you understand what a percent is. So I'm going to show you that a percent and a fraction really the exact same thing. If you understand what a fraction is, then you definitely already understand what a percent is. So the first thing to remember is that the word percent means per 100. That's what it means if you actually literally translate it. Percent means per 100. So when I say I have 50% of something, or 25% of something, or 10% of something, okay, what I'm saying is that I'm taking that number, 10%, 20%, 30%, and comparing it to 100. So just like any fraction, you take the top number and you're comparing it to the bottom parts of a whole. Well, in percents, it's just that the bottom number, what you're comparing it to, is always 100. Okay? So when I say 50%, I'm saying 50 out of 100, or 50 over 100. Or when I say 25%, I'm comparing it to 100. So it's 25 over 100. So it's actually easier in a way, because the word percent means over 100, or compared to 100, or out of 100. So if you understand that, then the rest of it is going to naturally come. So percents can be expressed in terms of a fraction, because 11% is 11 over 100, 11 out of 100, 11 over 100. That's a fraction. It can also be expressed as a decimal, and I'll show you how in just a second as well. So the fraction, the percent with the little percent symbol, and a fraction and a decimal, they all can mean the same thing. So 11% can be expressed as a fraction. I'll show you that in a minute. And that can also be expressed as a decimal. But they're all expressing the same thing. It's just different ways of saying the same thing. It's kind of like you look at a vase of flowers. You can say it's beautiful. You can say it's wonderful. You can say it smells great. You can say it's pretty. You can say all these different words that really just means that the flowers are they're nice, okay? Which is another word yet again, okay? Well, with percents, you know, you can express a percent with that little percent symbol. You can express it as a fraction. You can express it as a decimal. It's just different ways of saying the same thing, okay? So, just a little bit of review before we actually get into any word problems. Remember that, for instance, 11%, okay? That just means 11 over 100. That's all it means, okay? So anytime you see a percent symbol, it just means per 100, which means 11 over 100. And, you know, if you were to take a pie and chop it up into 100 pieces, which I can't do, chop it up into 100 pieces, and take 11 of them away, that would be 11%. 11 per 100, 11 out of 100. That is what percent means. They just invent this funny looking symbol to tell you that you're talking about 11 out of 100, okay? Now, you can also express it as a decimal, okay? So 11% is also 0.11. And the way that you do that is, because it's 11 out of 100, if you were to actually do this division, which, by the way, any fraction is division, if you were to take 11 and divide it by 100, the answer you would get would be 0.11, okay? So you can do that with any fraction to get it into a decimal, but the quick and dirty way is just to look at the percent, 11%, and, you know, after any number, there's an implied decimal point. You know, 23, there's really a decimal point here, 23.0. You know, for the number 57, there's really an implied decimal point here, 57.0. So just like there is here, there's an implied decimal point, 11.0%, right? So you just take that decimal point, you move it 2 places to the left, 1, 2, and that is how you express it in a decimal. So you see, this is super easy stuff, okay? 11% means per 100. So in order to express it as a fraction, you just put it over 100. In order to express it as a decimal, you take its decimal point, which is here, and you move it 2 places to the left, and you get it as a decimal. So just to drill it in, 13% would just be simply written as 13 over 100 if you wanted to write it as a fraction. And if you wanted to write it as a decimal, it would just be 0.13, taking that decimal point and moving it 2 places to the left. 25%, like 25% off sale, come in and buy our stuff. That means I'm taking 25 cents off of every 100 cents. Okay? 25 over 100, that fraction here. And it also is the same thing as moving this decimal point 2 places to the left. Okay? And just one more example. You know, they're all the same thing. 50% off, which just means I'm taking 50 cents out of every 100 cents away. I'm giving you a sale, okay? So I write it as 50 over 100, and as a decimal, you just move the decimal points 2 places to the left, okay? So I'm trying to show you by a bunch of examples that a percent is really just comparing it to 100, and if you were to do this math, you'd find out that you're just moving the decimal places 2 points to the left, so you can express any percent as a fraction and also as a decimal. It's very easy to move between them. If you were to see this decimal and you were, on a test and they say, hey, 0.50, what is that expressed in a percent? All you would do would be move the decimal point back 2 places. If they said, hey, what is 0.13 expressed as a fraction? You would move it 2 places to the right, 13%. If I gave you a fraction, I said, here's 25 over 100. What percent is that? You would know right away, well, it's over 100, it's just 25%, okay? So there's nothing magical here. If you've ever had problems with percents, it's just because maybe it wasn't quite explained this way. It's very easy stuff. You just put it over 100 for your fraction, move the decimal point for your decimal. So let's go ahead and use this information in some word problems. A class has 100 students. If 10 students made an A, what percent of the class made an A? And it also says, also express your answer as a decimal. So you see, you have 100 students in your class. If 10 students made an A, what percent of the students made an A? Okay. Well, what we're doing is we're comparing the 10 people that made an A to the 100 students in the class. 10 out of 100 students. And the definition of percent is comparing something to 100. So if 10 out of 100 people made an A, then 10% of the class made an A. And that's the answer, 10%. It also says express your answer as a decimal. You should know by now that you can take any percent and express it as a decimal by taking its decimal point, moving 2 spaces to the left, 0.10. So, for this problem, with 10 students making an A out of 100, that means that 10% of the class made an A. It also means that 0.10 of the class made an A. So it's really saying the same thing. The next problem says you have 100 apples in a basket. If 21 apples are rotten, what percentage of the apples are rotten? Also express your answer as a decimal. So it's asking for the percentage again. You see, and percent means per 100. How many out of 100? Well, here the problem says you have 100 apples. 21 of them are rotten. So that means that 21 out of 100 apples are rotten. Okay? And since it's out of 100 already, the problem has already given you some help. That means you can just read it right off. 21% of the apples are rotten. Okay? And because you can convert any percent into a decimal, you just take your decimal and move it 2 spots to the left, which is 0.21. That's how you would express it in terms of a decimal. So if 21 apples were rotten out of 100, that by definition means that that's 21%, which is 0.21. So you see, I'm easing you into it here. It's not very difficult, especially if you already have 100 apples. You already know what the percentage is because that's what the definition of percent is. Okay. Next question. Out of 100 televisions, 5 are defective. What percentage of TVs are defective? Also express your answer as a decimal. So this is the same thing. I'm just giving you another example just to drill it in. If 5 out of 100 televisions are defective, that is the definition of a percent compared to 100. 5 compared to 100 means that 5% are defective. Okay? Now, in order to take this and convert it to a decimal, you have to move it 2 places to the left. So that's going to be 0.5, and then moving it again is going to be 0.05. That's how you would express it as a decimal. Because if you have 5, which is 5%, and you move this decimal point here, that's one time, that's going to be 0.5. Well, you got to move it again. So you got to put a 0 here to move it again to 0.05. Okay? So you see it's the same thing. It's 5 out of 100 televisions. Means by definition, without any math, it's 5%, and you move the decimal point 2 times, 0.05 televisions. Okay, the next problem is a little bit different. I'm easing you into it here. It says there are 20 cars in a parking lot, and 5 of them are red. What percentage of the cars are red? Also express your answer as a decimal. So here you have not 100 cars, which is all the other problems we've had. We've had 100 of something. Here we only have 20 cars, okay? And 5 of them are red. And I'm trying to find this percentage. So following the same way as before, I know that 5 of them are red out of 20, okay? And I want to express this as a percentage. Well, the way you do this is a fraction, 5 out of 20. And it's not out of 100. It's not out of 100, so I can't just say it's 5% like I was doing before, because it's not 5 compared to 100, it's 5 compared to 20, so the answer is different. So the way you do this is you actually need to do this division, okay? You take 20 and you divide it into 5, okay? 5 divided by 20, 5 divided by 20. And whatever answer you get is going to be a decimal that you can then convert to a percent, okay? Now, what we want to do is, because we're dividing 20 into the small number 5, we want to make this 5.00, because that's going to allow us to do this division, okay? Because 20 doesn't go into 5 at all, let's go ahead and give it a few decimal points here. Because we're doing division, we're going to put a decimal point right above, just like we've always done in all of our division problems with decimals, okay? So now it just simply becomes a division problem. How many times can 20 go into 5? Can't go in at all. So I'm just going to go ahead and look at 50. Okay? How many times can 20 go into 50? Well, 20 times 1 is 20. 20 times 2 is 40. And 20 times 3 is 60. So that's too big. So it can only go 2 times. I'll put the 2 here because I'm looking at 50. 2 times 20 is 40. Okay? And I subtract. Okay? 0 times 0 gives me 0. I'm sorry, 0 minus 1 gives me 0. And 5 minus 4 gives me 1. And I've done this subtraction now, so the next thing I want to do is drop down my next digit. And then I want to ask myself, how many times does 20 go into 100? And I think you can convince yourself that it goes 5 times. Because 20 times 5 is 100. 5 times 0 is 0. 5 times 2 is 10. So it goes 5 times. Okay? Now after we've done that little division here, let's go ahead and do our multiplication and figure out if we're done. 5 times 20 gives us 100. 100 minus 100 gives us a 0. So we have no remainder, which means it goes exactly 0.25 times. Okay? So what we have found here is that the answer is, because we know we're comparing 5 to 20, we actually do the division and we find out that it goes 0.25 times, which is how we express it in terms of a decimal. And we also said that any decimal you can convert to a percent by just moving your decimal point to the right 2 times. So it's 25%. See, going from this step to this step is super easy because you just move your decimal point 2 times. So make sure you understand this. 5 cars in a parking lot compared to 20, we want to find the percent. So we actually have to do the division. Okay? We change it to 5.00 because this is the same as 5. Putting our decimal point up. 20 goes into 50 2 times, giving us 40. Subtract gives us 10. Drop down the 0 gives us 100. 20 goes into 100 5 times, and there's nothing else to do, so it goes to 0.25. So when you move that decimal point to the right twice, it gives you 25%. So these are the same expression. These are all exactly the same. 25%, 0.25, and 5 over 20. So these all mean exactly the same thing. 25%, 0.25, and 5 over 20. Now, one more thing before we move on to the next problem. I want to show you something because sometimes this is useful and it also makes it clear. The original problem said 5 cars were red out of 20 cars. Let's say I didn't do this division, okay? Let's say I just started with 5 over 20. We know from our previous problems that if I had 100 cars in the parking lot, 100 cars instead of 20, then I would just be able to read the percent right off the top because I already have it in terms of 100. Okay? So you should know by now that you can multiply a fraction by anything on the top and anything on the bottom as long as it's the same number. So what if I multiply by 5 over 5? After all, I'm just multiplying by 1. Okay, I'm just multiplying by 1. I can do that, right? 5 times 5 gives me 25. 20 times 5, we just did that a minute ago, gives us 100. I did this because I'm changing this denominator into 100. So what we're saying is this fraction, which is 5 over 20, is exactly the same fraction as 25 over 100. Even though they look different, it represents the same amount of stuff. And because it's over 100, you could then read right off of the top that the answer is 25%. Okay, which is exactly what we found the other way. So there's more than one way to do this, okay? And I'm trying to show you that here. If you can take your fraction and multiply it by something, top and bottom, to make the bottom equal to 100, then you can read the percentage right off the top like we did before. You're not going to always be able to do that, but it's instructive what's going on. Otherwise, you just do the division like we did, arrive at your decimal, move your decimal point to get your percent. Okay? So let's just continue getting some practice with this, and I think it will even become more clear. If there are 50 fish in a pond and you catch 10 of them, what percentage of the fish have you caught? Okay, what percentage of the fish have you caught? 50 fish in a pond and you only catch 10 of them. So you're not comparing this to 100. You want to compare it to 100, but you only have 50 fish in a pond, so it's not given to you in terms of 100 fish. So what we know off the top of our head is that we have caught 10 fish in a pond out of 50. Now we cannot just read the answer off because this is not 100. Now we can use our little trick that we did, and we can multiply this fraction by, what would we multiply by? 2 over 2. Because then the new fraction would be, on the top, 10 times 2 is 20, and 50 times 2 is 100. So this means, because now it's in terms of 100, it's just 20%. So I have caught 20% of the fish in that pond. If I have actually caught 10 out of 50, I've actually caught 20%. That's how you do that. But let's say you didn't think about that. Let's say that this just didn't occur to you, multiplying by 2 over 2, which is, by the way, multiplying by 1, so you don't change anything. Then the other way to do it, which is very important for you to know, is to actually do this division. 10 divided by 50 is going to be written like this, 10 divided by 50. Okay, and we want to go ahead and put a decimal here after there so that we can have a decimal up here, and what we're going to get is a decimal that we're going to then be able to express as a percent. So the question is, how many times can 50 go into 10? Well, it can't go at all. Okay, it can't go at all, so let's move on. How many times can 50 go into 100? Well, I think you all know it can go 2 times into 100 because 2 times 50 is 100. Okay? So let's do this. 2 times 50 gives me 100. 100 minus 100 gives me 0. I'm done. There's nothing more to do. Okay? I have divided into 100. I've got 0.2, which is 0.2. So the answer I got was 0.2. And then if I move the decimal point 2 places to the right, it's 0. If I move the decimal point to the right here, it's 2, and then one more time would be 20. And then that's expressing it as a percent, which is the exact same thing as what I got here. So I moved the decimal point once to the right, which was 2 point, and then had to move it again, so I had to insert a 0 here to do it here. And notice if I were to go the other way, I would take this decimal point and move it twice back here, which is what I started with. So there's more than one way to do things. And this is exactly what I chose to do here. You can try to multiply your fraction by something to give you a bottom number of 100, and then you can read the percent right off the top. Otherwise, you actually have to do the division. You'll get a decimal. You can move the decimal point 2 times to give you the percent. Okay, now the next problem says there are 30 crayons in a box. And if 27 of them are red, what percentage of the crayons are red? Okay, so again, we're comparing 27 to 30. Well, almost all of the crayons are red, but we want to know what percentage of them are red, which means we want to compare it to 100. But we don't have 100 crayons. So the best we can do is say that we have 27 out of 30 crayons that are red, and we want to see what percentage that is. Now the first thing I like to try to do is see if I can multiply this by top and bottom, something to give me 100. But there isn't a nice number to do that. 30 times 3 is 90, and 30 times 4 is 120. So I can't really do that very easily to take the easy way out. So I need to go and divide, and that's why it's so important to be able to know how to do that. So if I take 27 and divide by 30, I'm going to go ahead and add a 0 here with a decimal point, 27.0. So I'm going to have a decimal point in my answer. I'm going to get a decimal, and then I'm going to move that decimal point 2 times to the right, and that's going to give me a percent. So I'm going to do this division. Okay? How many times does 30 go into 27? Well, it goes 0 times, so I don't have to really do that. How many times does 30 go into 270? Okay? I think I can convince you it goes 9 times, because 30 times 9 is, 9 times 0 is 0. 9 times 3 is 27, 270. It goes exactly 9 times. So 9 times 30 is 270, okay? And I subtract, and I get 0. So there's no remainder. There's nothing more to do. It goes exactly 0.9 times, okay? It goes exactly 0.9 times. So then, the answer is just going to be, you can express it as a decimal, 0.9. Which is 0.90, okay? And then in order to move it to a percent, you move that decimal point 2 times to the right, which is 90%. So 90% of these crayons are red, which makes sense, because 27 out of 30 of them were red, which means that almost all of them were actually red, okay? So think about what that means. 90% of something is 90 out of 100. So that means almost all of whatever you're talking about was red. And that actually agrees with what we said here. So the percent is just kind of leveling the playing field so that everything you talk about is in terms of 100. Whether you're talking about 30 crayons or 64 boats or 27 cars, you can level the playing field, so to speak, and talk about a percentage, which will mean that if it were really 100 things, this is how many you would have to deal with there. And it makes it easy to compare two quantities. It makes it easy to talk about two different things when you use percents. So we'll have one final problem, and it says 30 of 40 days were rainy. So a lot of days were rainy out of these 40. 30 of 40 days were rainy. What percentage of days were rainy? So again, we want to know the percentage, which is out of 100, but we don't have 100 days. We have only 40 days. So how do we do it? Okay. Well, we know that 30 out of 40 days were rainy. 30 out of 40. Okay. It would be nice if I could multiply this fraction by something over something that would give me 100 on the bottom, but there is no good number, because 40 times 2 is 80, and 40 times 3 is 120. So I can't really do that. So I need to actually do this division. So I have 30 divided by 40. And I'm going to make it 30.0 because this is going to end up being a decimal in my answer. So I'll put the decimal point right above. How many times does 40 go into 30? It doesn't go at all. So I can not even do that. I can look at 300. How many times does 40 go into 300? And I think you'll agree that it goes 7 times, because 40 times 7, what does that give us? 7 times 0 is 0. 7 times 4 is 28. So if it goes 7 times, that's 280. And if it goes 8 times, that's going to be too many. It's going to be 320, so that's not going to be right. So it only goes 7 times, so I'll put a 7 up here. Okay? 7 times 4 is 280, and let's see what the remainder is. Okay? Let's see what the remainder is. 0 minus 0 is going to give me 0. 0 minus 8, you can't really do it, so I'm going to borrow. I'm going to make this a 10, and make this a 2 over here. Okay? So now I can do it. 10 minus 8 gives me 2. Okay, 10 minus 8 gives me 2, and 2 minus 2 gives me 0, so I don't even need to put that down. Okay, so now I have 20. I do have a remainder, okay, but I need to drop another digit down, so I'm going to create another 0 after the decimal point, which I can always do because you can add as many zeros after a decimal as you want. So now I have 200. How many times does 40 go into 200? The answer is 5, because 40 times 5, okay, is 5 times 0 is 0, 5 times 4 is 20. So that's 200 exactly. So it's 5. 5 times 40 gives me my 200, and I subtract and I get 0, so there's no more remainder. There's nothing left to divide. I'm done with this problem, and the answer is 0.75. So 0.75 of the days were rainy, and I can move this decimal point 2 times, which means 75%. Now let's see if this makes sense. 75% were rainy. Let's see if this makes sense. Okay, If 75 of them were rainy, 75%, that would mean that 75 out of every 100 days were rainy. That would mean a majority of the days were rainy. Okay? That makes somewhat sense with this, which was 30 out of 40 were rainy. So 75 out of 100, 30 out of 40. That seems about right. That ratio is about right. So we want to make sure that our answers make sense. This section dealt with introduction to percents, word problems in percents. I wanted to ease into it. So we have a part 1 and a part 2 of this section. And we did some word problems that dealt with percents and how to do the division and find out the percentage of something and convert the decimal to a percent. And we'll just take it from here and we'll go into the next section, which will have a little bit different flavor of problems that deal with percentages. And percentages are really nothing different than you already know. They're fractions, they're decimals, they're comparing something to 100. It's very useful to do because if I want to move, let's just say, if I want to move to Arizona because I like it there, okay, maybe I like sunny weather, it would be really nice to know how sunny is it, okay? So if I go off and I look it up and it says, well, it's sunny in Arizona 95% of the time. Well, that means that 95 out of every 100 days it's sunny. That gives me an idea of how sunny it is, okay? And I can compare that to another city, maybe Seattle or something. Maybe it's only sunny 50% of the time there. I can look at 50%, I can look at 90%, and I can compare the two because that gives me a good way, a good level way of comparing out of every 100 days which one is going to have more sunny days. So that's why percents are important, and that's why you need to learn how to master them.